In this video we have two integrals to evaluate. Both of them are trigonometric integrals. And for number one, I'm going to use a U-substitution. I'll let U equal what's in the denominator, 3 minus 2 cosine theta. Then du would equal to the derivative of 3 minus 2 cosine theta. Derivative of 3 would be 0. Derivative of cosine would be minus sine. I would cancel the negative here, so there would be a 2 sine theta. This is d theta here. I'm going to divide through by 2 here. This will cancel. So I need a representation for this integral in terms of u. So notice this product of sine theta d theta can be replaced by du over 2. I put the 1/2 out in front, and then this will be du. So I got du over u. This is just the integral that leads to your natural log of absolute u. 1/2 is a constant, so that's still going to be out there. And this will be the natural log of absolute u. But we've got to go to the original variable anyway, so let's go back, u equal to 3. So this gives me 1/2 the natural log of absolute 3 minus 2 cosine theta plus the constant of integration. That's it for the first integral. Now for the second one, the first method that I tried was I multiplied by 1. The old little trick here of multiplying by 1. So I multiplied the denominator by secant of x plus tangent of x. Multiply the numerator by the same thing. Secant of x plus tangent of x over secant of x plus tangent of x, that's just 1. So you never change an expression by multiplying by 1. Numerator will be multiplied by that. I'll have a secant x plus tangent x over the numerator, and then secant x minus tangent x multiplied by secant x plus tangent x. That's going to be secant squared minus tangent squared. That's just 1 by one of your Pythagorean identities. And it worked out okay. And I suggest you go ahead and try it that way and see what you get. Then what I did the second time, I said, well, let me try another method here. So I said, well, sometimes it works out if you just write everything in terms of sine and cosine. So I said, okay, secant of x is the same thing as 1 over cosine of x minus, and then tangent of x is the same thing as sine of x over cosine of x. And then I said, well, let's just simplify this and multiply through by cosine of x and cosine up here of x. Similar strategy, because cosine of x over cosine of x is 1. So I'm still multiplying the integrand by 1. So notice in the denominator, this cancels out, this cancels out. Numerator, I have cosine of x dx. So this becomes then, numerator, I simply have cosine of x dx. Denominator, I get 1 from this one right here. The cosine canceled. This is minus sine of x. So now I have the integral in terms of cosine and sine. And I know that the derivative of sine is cosine. So let's do this then. In this case, I let u equal to 1 minus sine of x. Then my du will equal to derivative of 1 is 0. And then the derivative of sine is cosine, but you have the minus there, so this will be minus cosine of x, and this will be dx. So multiplying both sides by a negative, here this will become a plus, and this will be a negative. So this is then equal to the integral cosine dx, that's replaced by minus du. I'll put the minus out in front. And then the 1 minus sine of x, that's u. This is minus, And the integral, same formula, which is used over and over again, of du over u is natural log of absolute u. Always go back to the original variable, so u is 1 minus sine. Put 1 minus sine of x here. This is plus your constant of integration. Now you can leave this as your answer. Minus natural log of 1 minus sine of x plus your constant of integration, or you can bring this negative using properties of logarithms. This will be a negative over here. This goes to the denominator, so you could rewrite this as absolute value of 1 over 1 minus sine of x. But you can leave it that way. Now, if you follow through with the suggestion that I made and multiply through by secant of x plus tangent of x, numerator and denominator, and carry out with the simplification of that, the answer comes out to this, just in case you want to play around with it. You do it the first way that I told you I did it, it comes out to natural log of absolute secant of x plus tangent of x minus the natural log of absolute cosine of x plus your constant of integration. So this is what you get if you multiply by secant of x plus tangent of x, numerator and denominator, follow through with the simplification. This is the answer you get here. This is the one that I get here. It's the same answer. It just looks different. So you want to do an exercise here. Can you show that this right here comes out to this? You can go the other way, but I would think it would be easier to do it the first way, using the properties of logarithms and basic algebra. You can show that this answer does simplify to this answer. So give it a try. Thanks for watching. We'll see you next time.